Alright, welcome back, ladies and gents. So the last couple of episodes, not a TV show, last couple of lectures, we've been talking about congruent figures, okay? So the warm-up question, what does it mean for two shapes to be congruent? So your packet yesterday should have helped you figure all of that out, okay? And to remind you at least. So today we're going to learn about similar figures. And similar figures have the same shape, but not the same size, okay? And the shape sides must have the same ratio in order to be considered similar, okay? So basically what happens with a similar figure is we'd have like two triangles, and the angles are all equal, or congruent in this case. But the sides are different, so this might be side 6, and this might be side 3, and this one might also be side 6, this one might be 3. So this one might be 4, and this one's 2. Okay, so they're the same shape. Obviously my picture's not cool. And they have the same angles, but their sides are different, okay? So we're going to talk about that a little further. So this first question is just identify two similar figures. Again, they're the same shape, same angles, but they are different sizes. So this trapezoid doesn't have another buddy. This square, there's another square down here, right? And notice that all four sides are equal. These ones have all four sides equal. 90, 90, 90, 90, 90, 90, 90, 90. Okay, so it's actually B and E are similar, okay? And I took a better picture this time so you guys can actually see what was going on. All right. So now I talked earlier about a ratio. So the ratio between two objects, okay? So I have two stamps here, and this is actually a picture in your book, so if you want to look at the color version, you can. So this little stamp is 3 centimeters by 2 centimeters, and then we're going to blow it up, so it's really 9 centimeters by 6 centimeters. And I want to find what's called the scale factor. And we dealt with the scale factor a little bit. But basically that's the new size over the old size. It's a fraction. Okay? So the new size stamp is, and I'm going to kind of look. This is the short side of the stamp, the long side. This is the short side, this is the long side, right? So the short side goes with the short side, the long side goes with the long side, okay? So I'm going to write the new over the old, which is going to be 6 over 2. Which equals 3. Okay. Now you could use these numbers too, new over old, and these two go together, right? So this would be 9 over 3, and 9 divided by 3 also equals 3. So the scale factor is 3. And you'll notice 2 times 3 gives me 6, 3 times 9 gives me 9. Or I'm sorry, 3 times 3 gives me 9, I apologize. Or vice versa, you could say 9 divided by 3 gives me 3, 6 divided by 3 gives me 2. So you can kind of have that area. So the proportions should equal. So EF over AB equals EH over AD. Okay, and that's just what this note says. Okay, and typically you do the new object over the old object, but it doesn't really matter either way. You'll get the same idea. You just have to use the scale factor differently. Okay. All right. Note with similar figures, the corresponding angles of the same will be the same measure in the shapes, and the sides will be proportionate to each other. So like if I gave you a triangle here, and I said this one is similar to it, and I said this angle is 65, and I asked you for what this angle is, those would just equal each other, okay? So that's all that means, is the corresponding angles will equal each other in a similar figure, okay? The next question is find the missing side length of xy. So I'm trying to find in this picture this length here, xy, using the scale factor. There are two ways to solve this. Proportions or finding the scale factor, then multiplying. I will show you both ways and you can choose which way you prefer, okay? So you might want to kind of watch me in both methods, then go back and just write down the method that you actually like to write. So for those of you who aren't actually listening to this video, that's where it's going to throw you off a little bit, okay? So the proportions way is harder in my opinion, but this will work every time for you, okay? Sorry, I know this picture's kind of dark. So what I'm looking at is, I know that 3 is going to go with the 6 because it's kind of the shorter side with the shorter side. And I know the 5 is going to go with the side that I don't know yet. Okay, so I'm going to, I know we know the numbers, but I'm going to set it up with letters. So I'm going to call this XL, because that side is XL, over UW has to equal, since I used the bigger whole triangle on the top, I want to use this side on the top, XY over UV. Okay. Now I'll actually plug in the numbers I know. So XL equals 6, UW equals 3. Okay, and then xy is some sort of x. I don't know. That's my question mark, right? So I'm going to call my question mark x, actually. And then it's over 5 because uv here equals 5. Okay. Now I have to solve my proportions, okay? Now, if you remember from 7th grade, to solve proportions, when you have two fractions equal to each other, you can do what's called the butterfly method and do 6 times 5. So 6 times 5, which that equals 30, right? And then you do the butterfly method and you multiply the diagonals here. So 3 times x, which is just 3x. And now it's a simple formula and you just solve for x. So I have to divide both sides by 3, so x equals 10. Okay. Now this way will work every time, like I said. But one of the shortcuts is finding the scale factor, right? So we found the scale factor in the last example. Just new over the old, right? So 6 divided by 3, and 6 divided by 3 is 2. So if this is the scale factor, every side that I multiply has to be multiplied by 2. So 5 times 2 is 10. So that equals my side xy. Now obviously this is much shorter, okay? But it's good to know this way as well, all right? So hopefully that works for you. I must not have written down the homework problems, but they will be on Google Classroom and on the whiteboard. Have a wonderful day. We'll talk to you tomorrow. Bye.